To understand the concept of the efficiency, we just take a simple example from the Hogg, McCain and Craig's book, that is page number 332. Let x1, x2 up to xn denotes the random sample from the Poisson distribution that has mean theta which is greater than 0. It is known that x bar is the MLE of theta. Show that it is also an efficient estimator of theta. So how we proceed for this one? The probability mass function of the Poisson distribution is, that is well known. We know that P of theta x, that is e raised to power minus theta, theta raised to power x over x factorial. And we also know that x varies from 0, 1 and up to so on. Suppose x1 up to xn are the n independent observation, then the likelihood function can be obtained as, that is for n observation, L of theta x, and that is equal to pi, I varies from 1 to n, that is P of theta x. And when we apply I varies from 1 to n to the probability mass function, we obtain that e raised to power minus n theta, theta raised to power sum x over sum into x factorial. So the log function, so that we can easily manipulate the things, we take the log of this function. So when we are taking the log, that is the standard notation, we can represent the capital L in small l. So that is basically small l represent the log likelihood function of the respective density. So that is minus n theta plus sum x log theta minus sum log x factorial. So when we take the derivative of this, that is curly L theta given x over curly theta, that will give us, that is minus n plus sum x over theta. And if we take the second derivative of this one, because we need it for the Fisher information matrix, that is curly 2L theta given x over curly theta square, and that is basically minus sum x over theta square. That is straightforward. So we know that I of theta, that is the Fisher information, and we know that that is equal to minus expected value of curly L theta given x over curly theta square, and that is equal to sum, that we have already find this amount, that is sum और expectation जो है वो variable के ऊपर apply हो जाएगी, and that is theta square. And we know that in Poisson distribution the expected value of x, that is equal to theta, it is well defined. So we can put this result here. So sum जो है ये n में convert हो जाएगा, because when we are going to take the expected value of the random variable, it converts to the constant quantity. So that is n theta over theta square. So this is equal to n over theta. And the variance of theta hat, which we need for to check the efficiency, that is 1 over I of theta, Cramer-Rowe inequality से, and that is equal to theta over n. And then we also know that, but we know that theta over n is the variance of x bar. How? We know that that is already well defined, that is variance of x bar, basically that is equal to 1 over variance of x, and we know that the variance of x in Poisson distribution, that is also equal to the mean of this one. So we can say that that is theta over n. So we know that theta over n is the variance of x bar. So hence x bar is an efficient estimator of theta. तो हमने ये प्रूव कर दिया है, क्योंकि जो हमने एस्टिमेटर लिया है वही उसका वेरिएंस बन जाता है, और क्रैमर रॉ इनइक्वालिटी में अगर वही उसका वेरिएंस बन जाता है तो वी से दैट इज द एफिशिएंट एस्टिमेटर.